Hello, this is James. I'm going to walk you through what we did in the first couple of lessons of Path to Programmable 2. Okay, so I'll start off just showing you what we got in the kit. So we got this box here with the Ultra 96 board, which I've got plugged in right here. So we open that up. The board itself actually came in wrapped in this anti-stat bag. We get a voucher for Vivado and some other tools. I've already redeemed this, so good luck trying to screenshot that and use it. Okay, here's a walkthrough of what's actually on the board. So just showing you where the different chips are. And the other thing that we get in here is a 16 gig Delkin SD card, which we'll probably use later on. If not, I will definitely be using in the second half of this program. The other main component that we get is the JTAG programmer, which came in this box. It's this component right here, which just plugs in to the side of the board. Okay, so that comes in wrapped in its own anti-stat bag, and it's got the similar walkthrough of the components on here. Here's the board itself. We've got a high-speed header, low-speed header. There's a Bluetooth and wireless card, USB downstream, USB upstream, display port, micro SD, and of course the JTAG headers. And the actual chip itself, the MPSoC, is on the back here, along with the flash memory. We can't really see in there, and there's a fan in here as well. Alright, I'll walk you through what we did in the first couple of lessons. Lesson 0 was, Lab 0 was setting up our virtual machine, and I've got Oracle VirtualBox I already had running. I had to make a new instance of it for this, and I did have some issues getting the guest add-ons for the shared clipboard and so on up and running. And once I did some updates, then that all came in. Got Vivado installed. And that was the main thing on lesson 0. Lab 1 was just getting Vivado launched, and we start off by creating a blank design, and we add the chip. So I'll show you in here. I'll open the block design that we came up with, and this is just adding the Zinc Ultra Scale by itself. And if I double click this, it goes in the configurator to recustomize it, and this gets into Lab 2. So in Lab 2, we come in and we check a couple of things, but a large part of it is just adding the serial port. I'll show you some of these screens on here that we've got. Okay, so here in the layout, we come in and we add UART1. You can see with a checkbox on here. So if I click that, it opens this screen, and UART1 shows up under I/O peripherals as one of the low speed. And we turn that on, and we hit OK. And that pretty much is it for this portion of Lab 2, but then we export it and we take it over in the SDK, where we import the wrapper. We create a board support package, and we write a program, and then we export that over and actually download it onto the board itself. And I'll show you what we do there. We run as, well, actually we create a new program called Hello World, and then we run that, and this comes over here. I did have to end up ticking reset entire system, so I was having a problem getting it to download properly. I also had to hit the reset button on the board itself. Okay, so once we do that, we hit run. It occasionally has a couple of pop-ups it'll ask you. Okay, there's already debug session active. Yes, okay, go ahead and relaunch it. And if I switch over to GKterm, just make sure in case there's any pop-ups here. So what this is going to do is it's showing down here the progress, okay, system reset, and it's pushing everything down. It's programming the FPGA here. Oops. Alright, let me pull that back down. Okay. And then it goes ahead and downloads everything down to the chip. Launching system debugger. And if we've done everything correct in Lab 2, we get a Hello World and a Hello Element 14. So that's it for Labs 0, 1, and 2. Thank you.